Hello, Katie and Laura in the future. Make sure you send us a message and tell us what stocks to invest in. Okay, here we go. So the first six were supposed to be easy, and then I made a whoopsie and one of them became very hard, but we'll get to that. Yeah, I actually meant them to be like no conservation, just quick, like calculate energy, but we saw what happened. Okay, so the first one is just potential energy. So potential energy is weight times what? With respect to some reference point that you get to decide. So actually, there's no absolute value for potential energy. Usually we say the ground, because that makes sense, because usually you fall to the ground, but the ground's not level. So, just based off of whatever you want to make your reference point. In this one, we're saying the change of potential energy, so we can have one exact answer. If we just said, what's the potential energy? Technically, all the answers would be right. And you could tell your teacher that. So that's why I was very careful and said change of energy. Because if it said energy, everything's right. Because you could just find a reference point that fits your answer and argue with me later. And you'd be right. So the change of energy as it's lifted from the ground to the top of the story is just weight times height. And the most common mistake here is people forget G. So just don't forget G. Mass is in kilograms, weight is in newtons, energy is in newtons times meters, where J stands for joules. Any questions on number one? By the way, if your homework grade is not 100%, you can do test corrections and show your work and get some extra credit. So you can do that while we're working. I'm going to say lifted from the ground, just in case someone wants to argue with me later. Yeah. Okay, next. So that was potential energy due to gravity. Next, we're going to talk about work and kinetic energy for the next two problems. So the first one says, if a real car, this is same picture as your practice questions, we just changed the mass. So if a real car goes over a rough flat surface with a coefficient of 0.41 and an initial velocity of 1 meter per second, what is the work done to the car from various forces? So you could put the car in the middle and draw the forces. We would have normal force going up. What's the work due to normal force? Always, always, always. 0, because it's perpendicular by definition. So just a reminder, the word normal is just a fancy word for perpendicular in 3 dimensions. So perpendicular is a definition in 2 dimensions. In real life, to be normal, you have to be perpendicular in all directions. So it's like, you can imagine you're on a hill and one side you're not perpendicular, one side. Anyway, it's 3 dimensions. So it's always normal no matter where you're going, even if you're traveling in 3 dimensions. So normal force is 0. What's the work due to gravity? In this case, also 0, because it's just canceling the normal force. And also, it's also perpendicular because in this case, we're flat. If it's not flat, we do have work due to gravity. But if we're just going on a flat surface, it's 0 and 0. So the answer is A. Okay, now for the one that was meant to be easy. No, so I'll let you into the process. Originally, this was supposed to test work equals force times distance times cosine of 0. And so in my original answer key, I'm not kidding, I circled the wrong answer. And then the morning of the test, I was looking at it. I'm like, wow, 1 meter per second is really slow. Maybe actually we stop. And so I added this phrase to try to help you because it was unintentionally difficult. So I added until it comes to rest and reprinted the whole test. Unfortunately for you, some people didn't notice until it comes to rest. So I didn't underline. I just typed it real quick and reprinted it. Yeah. So I don't know. I should underline and bold it. You say, Ethan, like this? Okay. Now I probably got to change it for next year anyway. But no, yeah. Until it comes. So the idea is this: if it comes to rest, we might not actually be going the full 2 meters. So that's the problem. If we get stuck in the mud and we go from our initial velocity to 0, we're not actually going to be going the full 2 meters. So we can't do work times distance. With that in mind, knowing that it comes to rest, then it becomes clear that, okay, so what will be the change? Well, it'll just be our initial energy going to 0. So the change of energy. So initially, we have only kinetic energy, and we just calculate the kinetic energy, and that'll be the answer. But with a negative, because we lost it. Yeah? Questions? When you explain it like that, it sounds so easy, Mr. Rickard. If only I saw that on the test, right? Who got this one right? I'm curious. Andrew? B. Yeah, Andrew and Alice. Good job. Everyone else did the work equation. So yeah, I think I'll pick on Aaron. So did you just skip this part of the question until it comes to rest?
I did.
Or you?
The practice.
Oh, so you were thinking about the practice. Yeah. Okay. Yeah. So very important. You'll see questions even on the AP test that look familiar. Make sure you read it completely and take your time, because we can change, if we change the parameters just a little bit, it can change the question completely, especially if it has to do with friction, as you've seen many times in this class in both MCQs and FRQs. Yeah, friction, so much fun. Okay, next, spring energy. We give you all the information, which is nice of us, so you don't have to derive anything. Again, this is kind of, other than 3, which was unintentionally difficult, this is kind of easier version than the quiz even. So now we're quizzing you on potential spring energy. So we just plug into our equation, 1/2 kx squared. So what is our compression in the initial position? How much did we move? Not a trick question. What was our initial compression, Alice? Yeah, just 2 meters, right? Yeah. So we just plug that in. 2 squared is 4. 1/2 of 2 is 2, because, multiplication, we can move stuff around if it makes our lives easier. So 2 times K is 300 joules. If you plug in all the units and do dimensional analysis, you'll see that again, you get newtons times meters, which is joules. Always a good thing to check. Or you can just remember energy is always joules. So the answer is 300. Importantly, on the AP test, sometimes they try to trick you by giving you other distances like this, or other distances. So it's always, the energy is from compression. So whatever you compressed is the energy. That kind of leads us to number 5. Here we are now compressed to 1 meter. So it's the second picture, and we're already moving. And we want to know what's its velocity. So basically, how much spring energy does it have now? And the change of that is the velocity. So velocity is kind of responding to all the other forms of energy. So we plug back in. We notice that even though we're half the distance, we've lost 3/4 of the energy, because that's how springs work. And we plug in, so 1 squared is 1, 1/2 of 1 times 150 is 75 joules. So we still have 75 joules from the spring. We started with 300. So we have 225 joules available for us to go. So we just plug that into our kinetic energy equation. So we get 550 joules because it's a 1/2, divided by the mass, which is 4. So 550 divided by 4 is 132.5. And then we square root that. So you should get rounded answer close to 11. What was the exact answer? Anybody have it written down? Yeah. Yeah. So we can round it for significant figure reasons. Yeah. Yeah, so we still have spring energy. That's important. As long as the spring is not at its, see, this is the rest position. As long as the spring is not back here, we still have spring energy. So it does not all become velocity. Yeah. If you want to be systematic, another way you can do it is do energy diagram. So here we have all spring energy. Here we have a little spring energy and kinetic energy. If you set them equal to each other, Jade, you'll get the right answer for velocity. Ooh, everyone's so tired today. Yeah. Number 6. What forms of energy are present? Well, we just said spring energy and kinetic energy. So I don't know how you would get 5 right and not 6. That would be difficult, unless you're really good at guessing. Okay, next. What if we're going down a ramp? So we're kind of adding more and more difficulties as we go in the multiple choice section. What if we're on a ramp? So there's now angles. And important, the angle should be 37 degrees, not 30 degrees. So first, what is the initial energy of the box? If it's 37 degrees, what are the sides of this triangle? Three, 4, 5. Yeah. So, Brittany, what's the height? If it's 30, yeah. That was the whole thing. So as labeled, it's 2.5, and someone pointed out to me on the test that the angle was wrong, so I changed to 37 degrees to make it 3. So if we do have a height of 3, I'm gonna make my life easier. So we're gonna delete this. And next year, we'll actually have the right height. So 2.5 times 4 is 10 times 10, so 100 joules, right? Okay, but if the height was 3, then it's 120 joules. Oh, just kidding. 108? Yeah. 128 is the answer for the 37 degrees. Yeah. I added initial velocity here. Again, I just wanted to change it up a little bit from the practice questions. Okay, what could be the speed of the box once it reaches the end of the ramp? If you work it out, you should get a speed of 8 meters per second as a max speed. So anytime we're calculating for a conservation of energy problem, we're assuming it's 100%. But in real life, is it always 100%? So if we're gonna say what could be the speed, the best answer is D. There could be a little bit of friction or energy loss. For a system in which there's only one object, what best describes the energy of the system? If we only have one object, can we have spring energy? Why not? Yeah, no spring to push on the object, or we're ignoring it. Can we have gravitational energy? No. We're ignoring the Earth for very suspicious reasons. And then, so basically, if you only have one object, you only have kinetic energy. And they like to ask that type of thing on the AP test for strange reasons. But I mean, they're just really emphasizing that it matters what the system is. Which of the following best describes the work due to friction? It will be negative. Yeah, as I teach you in this class, it's D. There could be an argument on that it could be positive, negative, or zero. And lots of people like to argue about this on the internet. But I added this phrase, so this wouldn't be a possible answer. So it doesn't depend on the angle of the ramp. Why does it definitely not depend on the angle of the ramp? Yeah, even if you're going down a ramp or any shape, friction should be anti-parallel. So on the internet, there was lots of physics people arguing about this because they said, well, if you're running, you're pushing off the ground, so it's doing positive work because it's giving you kinetic energy. And then other physics people were saying, no, in your frame of reference, it's negative work. And they were arguing, yeah, they were going back and forth for like lots of stuff. So, you know, that's what happens in the comment sections. So maybe we could say it's positive, but the best way to think about it that's easy is friction means the cosine of the angle is always 180, so it's always -1. If you do that on the AP test, that's the easiest way to think about it. Now for the brand new question worth 5 points. So as drawn, we see we definitely have a spring. So we're going to have spring energy. We see a weird green brown patch. So there might be some friction. Then we go down a hill and up a hill. The intention of this was actually to help make your lives easier, because in the practice question, we just went up and then we had extra heights. And so I made it go down then up. So the launch point would be the same as the initial height. But then people still got confused. But again, you shouldn't expect the practice test to be exactly like the test in this class. I'm going to change at least something. So we launch from the initial height, we go into the air, and then we hit the ground and break. So that was the drawing as I intended it. A couple important mistakes I made. Number one, I gave you two different heights, which disagreed. So I said 10 meters up here, and then later I said 5 meters. So I had to grade. It just made my life a lot more difficult. I had to make sure I gave you points if you used either ones. So if I marked you wrong for using 5 or 10, let me know. But I think in the regrade, I gave points to everyone who used 5 as well. I intended it to be 10, but I added contradictory information later on. First, we do the energy diagram, and thank you for everyone who read this and used the answer space. Importantly, on the AP test, if you write on the question, you don't get graded. So you have to use the answer space. So I'm just trying to get you in that habit. Also, I'm trying to make my life easier because there wasn't a lot of space here. So first we have initial energy due to a spring. That's it. It's not moving yet. And it does say rest somewhere in the paragraph. Then the tricky part about here is we added work due to friction, which many of you remembered. So I was happy about that. It was about 50-50. 50% of the people who made a mistake forgot work due to friction, and 50% of people who made a mistake forgot that it's still moving even at the max height. So just keep both of those things in mind. Is if you're moving, you have kinetic energy, even if you're at max height. The only reason we say velocity equals 0 at max height is because what is always true is that the vertical velocity is 0. That's always true, but not necessarily the horizontal velocity. And you can see that in my tiny new equations I added for you that actually was there during the test, but no one noticed, 2a and 2b, which shows,
Oh my God.
yeah, it was actually there during the test, but no one. So that's what I used to make the answer key for this question. So you can actually calculate the horizontal velocity and the horizontal and vertical velocity and the horizontal position and vertical position, which becomes important for part D, which I think only Ethan did. I think everyone else started and gave up. Did anyone else try? You started, but you didn't. Yeah, I think everyone else gave up. So, which is understandable. But you have to use those equations. And then there's lots of sines and cosines. And yeah, it's just a very monstrous equations with lots of trig. So that's so fun. Okay. So that's A. Everyone clear on A? We'll pick on Maggie because she hasn't participated yet. How come there's work due to friction even though we're in the air? Let's see if we understand. No, it's because we're comparing from here to here. So to compare the energy, along the way, we lost energy due to friction. So whenever we're comparing 2 points, we're comparing what happened in between as well. Because we're not going to have all kinetic energy. We went through this rough patch. This is like, junior year when you take all those AP classes and you get some bad test or get dropped from AP bio, and you go through a little rough patch, but then you go back to the smooth path and you're off to college. So yeah. I was like AP bio or AP computer science or whatever. You like computer science? It's a lot of work. No? Ethan's saying no, and everyone else everyone else. Oh, okay, everyone else I talked to is like so much work. Okay. Derived for velocity. So importantly, if you have a equation that says V equals and it's consistent with your energy diagram, you got full credit, even if it's wrong. So make sure when you derive an equation, you say V naught initial velocity equals something based off your energy diagram. It should all have a square root, and it should have lots of 2's and over m's, because you have 1/2 mv squared. So you have to multiply everything by 2 and divide everything by the mass. Take a big square root. Importantly, for derived equations on the AP test, you're not supposed to plug in anything. You just write an equation. Then for the next one, you're supposed to plug stuff in. But I kind of botched this one because I gave you a bad height. But you got full credit if you plug things into the right places. So that's all you had to do for that one. Lastly, we had an overambitious question that you don't have to worry about. If you want to see the answer, I started it in the answer key. And then maybe didn't even finish. Yeah. Okay. FRQ 2 and 3 were quick ones that you could have actually done very quickly and got full credit, mainly because I made another mistake, as we'll see. But the mistake was good for you because it made the grading points for 3 go from only 2 people getting it right to almost everyone getting it right. So as you'll see. Okay, number 2, force diagrams. Everyone forgot how to do this. It is fair game for me to ask you stuff from previous units. So you need to review force diagrams before the AP test. The way the AP test works is if they might say draw force diagrams and it's worth 5 points just for a force diagram. So they like these type of questions. Importantly, force diagrams should only show forces, not acceleration or velocity or anything else. That was the most common mistake. The second most common mistake was forgetting about the magnitudes, which I've already berated you about before. So I refer you to my previous berating about making the magnitudes right. Then you're supposed to derive an equation for work. For this one, because we don't know very much, you can estimate the angle and get it in terms of the radius like I did, or you can do what everyone else did and just leave D. And I accepted that. I mean, you could estimate this is about 1/5. That's what I estimated. 1/5 of the entire radius, and then you can actually calculate. Not so necessary. Unfortunately, we don't give you an angle, we don't give you lots of stuff, so you could just leave it as D. If they label it on the picture, then just use whatever the label is. Then C, did I mark anyone wrong for C? Everyone should got at least half a point. So as long as you said there's friction and we're going back and forth, I didn't give you any grade, Brittany. You earned your grade. I heard he gave me 0. You earned 0. Yeah, don't add cosines. Not good. -1 for friction. Always, always, always. So C, describe, just write a sentence or two saying we're not going to go as high due to friction. Most of you did that, so I'm happy. Last but not least, your favorite question from last unit. Actually, this was way easier than last unit because energy is actually easier. You don't actually need to calculate the acceleration to do like energy diagram. So you should be seeing the value of doing things with energy. And the rule of thumb for the AP test is suck your thumb. No, wait, don't do that. The rule of thumb is if you can use energy, use energy. So you can actually calculate like velocity and everything without using energy. You can do like force and acceleration and find the center of mass, or you can just do energy and it takes like 1 minute. Let me show you. So derive the initial energy. It's not moving, no kinetic energy. This is off the ground at a height of h. So m2gh. I'm done with part A. Derive the potential energy after 1 second. Now they're both in the air. The potential energy is m1gh, m2gh prime. So just call it h prime. What's the kinetic energy? It's equal to the change of that. So you just do that equation minus the initial equation. Done. 1 minute. Now, why you should be happy is what I'm going to do next year is for this one, see how I said assume height is greater than 10? I'm going to actually make them calculate the acceleration and actually plug in value for h prime. So actually figure out how far they move. So it won't be in terms of, yeah, they will actually have to do it. But for you, I didn't actually say that. I just said figure out the energy in terms of M1, G, and H. So you don't have to do anything too much. Okay. Any questions on the test? Last chance. Again, if you do some corrections, you'll get some homework credit. If your homework is not 100%, if it's 100%, I don't believe in extra over 100%. Also, Ms. Hoffman, who's the department chair, said it's not allowed. So can't have any grades over 100%. Okay, let's take a 5-minute break and then we're going to start our new unit.